Welcome back, students. In this class we will be studying how to identify the type of conic given its general equations. As you are aware, we have studied already the circles, the parabolas, the ellipse and the hyperbolas. Now all of these form the general conic. Now it is imperative that when they give you the general equation of a conic, now this is the general equation of a conic and you should never forget this. It is written of this form: ax squared positive bxy positive cy squared positive dx positive ey positive f is equal to 0. Now, of course, when we studied the circles, we have given the equation of the circle of the form x squared positive y squared positive 2gx positive 2fy positive c is equal to 0. Now this occurs because of the values that a, b, c, d, e, f are assigned to. So you should also remember that we also studied the parabolas, and under parabola we add the equation of the parabola to be as y squared equal to 4ax, and similarly for x and y. And we also studied different variation of parabolas like y negative k raised to the power 2 is equal to some constant times of x negative h. So these are all occurring because of the values that a, b, c, d, e, f are being assigned to, or the values that they take. Now, having said that, what we are going to do is we are going to write down the conditions that are necessary or that you have to check whenever the equation is given. So I'm going to write down the conditions for each of the conics that we have studied. So for the circle, what you have to look for, you have to always make sure that the coefficient of a and c are always equal and that they lead to 1. Now at times it is always possible that the coefficients are equal but they are not equal to 1. In that case you can suitably use your judgment in converting the equation to a given circle. So make sure that you are able to understand that. Say for example, if I have a system like this, say 2x squared positive 2y squared is equal to say 64. In this case, a is equal to c, but they are not equal to 1, but they are equal to 2. Okay, so what can I do here? I can simply divide by 2 throughout, and by doing that, this is going to become 2x squared divided by 2 positive 2y squared divided by 2 is equal to 64 divided by 2, which is going to lead me to x squared positive y squared is equal to 32, which is equation of a circle. So generally speaking, a and c have to be equal, and when they are equal to 1, we are getting a circle. So this is the final condition that is being spoken about here. So you have to use your judgment. Now, having obtained the circle, let us go forward in obtaining the parabola. Now, before we could go to circle, you should also note here that the bxy term, in other words, the b term, is actually missing. So we need to add that condition also. So b should be equal to 0. Of course, in this case, you have to also note here that d is taking the place of 2g and e is taking the place of 2f and f is taking the place of positive c. So in this case, suitably what we need to do is we can either mention this or we can simply note this important information where coefficient of x is existing, coefficient of y is existing. So this would be sufficient enough to get the circle. So these conditions, so a should be equal to c and that leads to 1, and b should always be equal to 0. So having obtained this, let us move on. Now the parabola, so we have studied the parabola, and for this parabola the important condition that you need to look for is that b should be equal to 0 and either a should be equal to 0 or c should be equal to 0. So this is the condition. So either a should be equal to 0 or c should be equal to 0. So in this case, b is equal to 0 is a necessary condition, and either a is equal to 0 or c is equal to 0. Okay. So this is just a coding representation, but this is just an expansion of the language. Okay, so having said that, let us move on for obtaining the ellipse. Now for the ellipse, the condition is that a cannot be equal to c, and a and c should have, should have the same sign. They should have the same sign. Have that in mind. If I were to take the standard form of the ellipse, x squared over a squared positive y squared over b squared is equal to 1. Now clearly, if you can see here, the sign of x squared and y squared are the same. Okay, so that's what we are looking for. A and c should have the same sign. So in this case, if you move up here, a and c, we're looking for a and c to have the same sign. So why do I say a not equal to c? A and c, say suppose we are obtained or we are given this system, say 4x squared positive 16 y squared is equal to 64. We are given this, okay? So this is Conic's equation. Clearly we can see the sign of x squared and y squared are same, but the coefficient coming with x squared and the coefficient coming with y squared are not the same. So this is what they are talking about when they are talking about for an ellipse. A and c should not be equal to each other, and that a and c should have the same sign. This is what they are talking about. So in this case, if we were to divide both sides, divide by 64, then we would get 4 times x squared divided by 64 positive 16 times y squared divided by 64 is equal to 64 divided by 64. In this case, it's going to be x squared divided by 16 positive y squared divided by 4 is equal to 1, which is the equation of the ellipse. So I hope you're able to catch the gist of it when they are talking about that the coefficient of a should not be equal to the coefficient of c, and that a and c should have the same sign. So having said that, moving on. After the ellipse, we have to look for the hyperbola. The condition for the hyperbola is that, of course, a cannot be equal to c. The coefficient of a cannot be equal to the coefficient of c. And a and the c should have opposite signs. Should be of opposite signs. That is understandable because the standard form of the hyperbola is going to be x squared over a squared negative y squared over b squared is equal to 1. This is the standard form. The negative sign should prevail. So if I were to give an example, say 25 times x squared negative 125, say 125 times y squared is equal to say 625. Say suppose we got something like this. So clearly if I were to divide, so in this case you see the coefficient of x squared is 25, coefficient of y squared is negative, it's 125, but the signs between x squared and y squared are different. So this is the equation of a conic. Okay, equation of conic where the coefficient of a and c are not equal, the signs of a and c are not equal. Of course, the terms that we talked about, b is equal to 0. We are not having any b term here. So in this case, we can convert this into the standard equation just by dividing by 625 both sides. So this is going to be 25 x squared divided by 625 negative 125 y squared divided by 625 is equal to 625 divided by 625. So if we were to do this, 25 divided 625 how many times? 25 times. 25 times 25 gives you 625. So this is going to be x squared divided by 25 negative y squared divided by. So 125 divides 625. How many times? So this is going to give me 5, because 125 divides 625 5 times, and this is going to give me 1. So this is the equation of the hyperbola. So I hope you are able to understand the entire concept of identifying a conic. So just to recap, the most important concept that you have to know is the general equation of the conic, which is ax squared positive, bxy positive, cy squared positive, dx positive, ey positive, f is equal to 0. So having obtained this, there is two other things which you have to know when it comes to obtaining the conic's shape. Now the final one, in fact last but not the least, if A is equal to C and B is equal to D is equal to E is equal to F is equal to 0. So all of these things are equal to 0. Then you produce a conic which is x squared positive y squared is equal to 0. That means this is what you are getting. And what is this? This is called a point. Okay. X squared positive y squared is equal to 0 gives a point because the radius is 0 there. So having obtained that, we got three more to go. So next is condition number 6. In condition number 6, we have got A is equal to C is equal to F and B is equal to D is equal to E is equal to 0. We get the form to be as x squared positive y squared positive 1 is equal to 0. And this has no real solution. Have it in mind. And it yields, it gives us, okay, it gives us an empty set. So imagine they're asking you a question. Find the conic or write the necessary condition for a conic to produce an empty set. So this is the necessary condition. And if they ask you another question, what is the system that represents an empty set? So you have to write that down. X squared positive y squared positive 1 is equal to 0 is a system. And why is it empty? Because it has no real solution. So having mentioned this, make sure that you are able to remember these concepts. It's critical. Remembering these things is important. Have that in mind. So next is condition number 7. Now A is not equal to 0 or C is not equal to 0. And this is a conic that yields coordinate axis. Okay. Now you might be asking yourself, why do we need all these things? Look, you have to understand that we are now in the digital age. That means you should be able to design programs that they are asking you for. In other words, imagine you want to generate all the conics. So you would only be able to generate all these conics if you are clearly aware of the general conditions where and how these coordinates or these coefficients become 0. So if you want to get the coordinate axis on a graphing calculator or if you are asked to design a graphing program, you have to generate this coordinate axis. Okay, so to generate the coordinate axis from the given conic, what you have to do, you have to look for making A and C, okay, not being equal to 0, and others are 0. So I have to write that, and all others and all other quantities that we have got. That means B is equal to 0, D is equal to 0, E is equal to 0, and F is equal to 0. So to design or to get the axis on the graphing calculator, you should ensure that B, D, E, F becomes 0 and that A or C is not equal to 0. So this is just an illustration that I wish to state here, that why these conditions are required. So the final condition that we are going about is when A is equal to negative C and B is equal to D is equal to E is equal to F is equal to 0. We got pairs, okay, pair of lines which is represented as x squared negative y squared is equal to 0. So this is a system which gives us the pair of lines. So when this occurs, we are getting a pair of lines. And having mentioned all this, this completes our lesson on identifying conic.